There is a room in Dresden, Germany, that most tourists never find. It is not on the main tour route. It sits behind a curved pane of climate-controlled glass, inside a sealed case on the third floor of the Sächsische Landesbibliothek. The Saxon State Library, protected from light, humidity, and human breath at a temperature that never fluctuates by more than 2 degrees Celsius. Most people walk right past it. It looks, at first glance, like folded bark paper, roughly 12 feet long when fully unfolded, covered in columns of red and black ink, painted by hands that have been dust for 700 years, marked with symbols that look, to the untrained eye, like stylized figures, animals, and abstract ornaments. It is called the Dresden Codex. Catalog reference MSCRA, Dresd, R.310, and hidden inside it is something that shouldn't exist. Not a religious story, not a mythological poem, not a king's lineage or a harvest prayer. Numbers, astronomical calculations of impossible precision. Calculations that project backward through time, not just centuries, not just millennia, but more than 28,000 years into the past, before the Maya civilization existed, before any known Mesoamerican settlement, before the end of the last ice age, before Homo sapiens had a single city, a single field, or a single written word anywhere on Earth. And when modern astrophysicists fed those numbers into planetary simulation software, running the calculations against independently computed planetary positions, the Dresden Codex was accurate to within 2 hours over 481 years of continuous tracking. 2 hours over nearly 5 centuries of accumulated celestial motion. That is not mythology. That is not coincidence. That is precision engineering applied to time itself. And the question that serious researchers have been quietly circling for decades, the question that does not have a clean answer, is devastatingly simple. How did they do it? And how far back does the knowledge go? If this channel is new to you, subscribe right now, because what we are about to examine is not the popular version of the Maya calendar story, not the 2012 media circus, not the apocalypse narrative that every documentary recycled for 10 years. What we are going to look at is the actual mathematics, the actual computational architecture of one of the most sophisticated astronomical systems in human history. And the evidence, documented, peer-reviewed, quietly published, and then largely ignored, that the Maya may not have invented this system at all. They may have inherited it. Let's start from the beginning. The Dresden Codex was first encountered by European scholars in 1739, when Johann Christian Goetze, the director of the Royal Library in Dresden, purchased it from a private collector in Vienna. No acquisition records preceded that transaction. No provenance trail existed beyond the Viennese collection. How it traveled from the Yucatan Peninsula to Central Europe between the 16th century Spanish conquest and the 18th century library purchase is a question that has never been answered with certainty. It survived narrowly the Allied bombing of Dresden in February 1945. Wartime documents record that the Codex sustained water damage and partial degradation during the fires that followed the bombing, and that it was recovered from the ruins of the library, dried, and stabilized by staff who apparently understood they were holding something irreplaceable. The Codex itself dates, in its current form, to approximately 1210 CE, but the content it records is almost certainly much older. Multiple Maya epigraphers, including J. Eric Thompson and later Linda Shell, argued in published work that the Dresden Codex is a faithful copy of an original manuscript that may predate it by 3 to 4 centuries, at minimum. Some researchers place the original astronomical observations it encodes even further back, into the pre-classic or early classic Maya period, before 400 CE. For most of the 18th and 19th centuries, Western scholars looked at the Dresden Codex and saw what they expected to see: ritual imagery, ceremonial documentation. Mythology painted on processed bark, from the fig tree Ficus aurea. The symbols were unreadable. The tables were opaque. The figures of gods performing gestures over columns of dots and bars. The Maya numerical notation system looked like superstition organized into charts. For decades, scholars dismissed it as symbolic. Then, modern science found something that changed everything. Beginning in the late 19th century, with Ernst Fürstemann, the librarian in Dresden, who was the first to realize the Codex's astronomical content, and accelerating through the mid-20th century with the systematic decipherment of Maya script, researchers began to understand what they were actually looking at. The Dresden Codex is not a prayer book. It is not ceremonial decoration. It is a technical almanac, a computational manual, a working instrument for predicting celestial events across generations. Here's where it gets strange. Among the dozens of tables and almanacs in the Codex, there are pages that resist easy explanation, pages that carry no obvious ritual purpose, pages that do not correspond to any known ceremony, any identifiable Maya ruler, or any single astronomical event. They run from pages 61 through 69. Scholars labeled them the Serpent Number pages, after the serpent imagery framing each table. And for most of the 20th century, they were the most poorly understood section of the entire document. The Serpent Numbers encode a date, not a date in Maya history, not a date in any civilization's recorded past. They reach back to a computational base point that, when converted to our calendar using the most widely accepted Maya to Gregorian correlation, the GMT correlation, formulated by Goodman, Martinez, and Thompson, 1, falls in approximately 23,400 BCE, deep in the Upper Paleolithic, the era of the Lascaux cave paintings, the era before the domestication of any crop, any animal, any organized settlement. The era when Homo sapiens shared the planet with Neanderthals, who had not yet vanished. The Maya scribes were not writing about that era. They were calculating from it. Now, the mainstream explanation is that the scribes were performing mathematical extrapolation, projecting known astronomical cycles backward using the same logical framework that modern astronomers use when they compute where Jupiter was on a specific night 10,000 years ago. Cycles do not require observation to project. You can extend them mathematically. But that explanation has a problem. The problem is precision. The problem is the error rate. Mathematical extrapolation accumulates errors. Small discrepancies in a base cycle, repeated across hundreds of iterations, compound. The further you project from an observational anchor, the more the numbers drift from reality. This is a well-understood limitation of all predictive astronomy. It is why ancient Babylonian astronomical records, which were meticulous and mathematically sophisticated, show increasing drift in their long-range predictions, because even a tiny inaccuracy in a base cycle becomes significant when multiplied across centuries. The Dresden Codex does not show this drift. The Venus tables maintain accuracy across 481 years with a total accumulated error of less than 2 hours. The eclipse tables, which run across 405 lunar months in a single uninterrupted sequence, correctly predict the timing of lunar eclipses that can be independently verified against the astronomical record. Errors that small, maintained across timescales that long, require something more than mathematical projection from a single baseline. They require correction. They require someone, at multiple points along the observational chain, watching the sky, comparing predictions to reality, and adjusting the numbers. They weren't guessing. They were recording. Now let's look at the first major clue. The Venus table in the Dresden Codex occupies pages 46 through 50. It tracks a celestial object the Maya called Chak-Ek, the Great Star. Venus. Specifically, it tracks the planet's synodic cycle, the 584-day interval between successive apparitions of Venus in the same position relative to the Sun as seen from Earth. The table is divided into sections corresponding to each phase of Venus's cycle, as morning star, superior conjunction, evening star, and inferior conjunction. The actual modern value for the Venus synodic period is 583.92 days. The Maya base number is 584, an error of 0.08 days per cycle. Over 301 cycles, the span covered by the Dresden Codex Venus table, that error would compound to approximately 24 days of total drift if uncorrected. The Codex contains correction factors, small adjustments embedded in the table at specific intervals, at the 57th cycle, at the 61st, at specific named dates, that pull the running total back into alignment with observed reality. After correction, the total accumulated error across 481 years is under 2 hours. The people who built this table were watching Venus with the methodical consistency of a modern observatory. Not one astronomer, not one generation. A chain of observers maintaining records across centuries without interruption severe enough to break the correction sequence. That is not astrology. That is science. Now, let's look at the second clue. In May of 2012, an excavation team led by William Saturno of Boston University was clearing rubble from a storage chamber at the ancient Maya site of Xultún in the Petén region of northeastern Guatemala. The site coordinates place it at 17 degrees, 23 minutes north latitude, 89 degrees, 37 minutes west longitude, deep in a jungle that has been reclaiming the ruins for more than 1,000 years. The room was small, roughly 1.5 by 1.8 meters. It had been sealed since approximately 800 CE. When the team cleaned the interior walls, they found paintings, not ceremonial murals, not portraits of kings or gods receiving tribute. On every wall, from floor to ceiling, painted directly onto the plaster in red and black, were columns of numbers, astronomical tables. The Xultún murals, as they came to be known, showed 4 separate cyclical systems running simultaneously and interlocking. The 365-day solar Hab calendar, the 260-day sacred Tzolk'in calendar, the 584-day Venus synodic cycle, and a 177-day table, almost certainly corresponding to lunar eclipse seasons. Not listed separately, interleaved in a single computational grid. The grid projected these 4 cycles forward across their combined repeat period, a span of approximately 17,000 years. Let that land for a moment. 17,000 years. The calculations painted on the walls of a storage room, smaller than a large closet, extended 13 times further into the future than the entire span of recorded human civilization, from the first Sumerian cities to today. And here is what made Saturno's team fall silent when the data came back. The Xultún tables matched the Dresden Codex methodology almost exactly. Same base cycles, same correction structure, same interlocking framework, same mathematical architecture. The Xultún murals predate the Dresden Codex by approximately 4 centuries. They predate the oldest known copy of the Codex's original source material by at least 2 centuries, which means that the system we see in the Dresden Codex, already a copy of something older, was not developed by the scribes who produced it. It was inherited. It was already complete when they received it. And when it was painted on the walls of a sealed room in Xultún in 800 CE, it was already old. Not similar to an earlier system. Not inspired by an earlier system. The same. Now let's look at the third clue. In the Serpent Number pages of the Dresden Codex, researchers have identified a specific interval number written in Maya positional notation as 1.5.5.0. Converted to days using the standard vigesimal Maya counting system, this equals 341,640 days. Divided by 365.25, the Julian year, This converts to approximately 935 years and 4 months. For most of the 20th century, this number was a puzzle. It does not correspond to the calendar round, the 52-year interlocking of the Hab and Xultún. It is not a Xultún multiple, not a Baktun multiple, not any obvious subdivision of the long count. It was treated as a computational artifact, a number that served a technical purpose within the table structure, but had no external astronomical meaning. Then researchers began running it against longer astronomical cycles. The precession of the equinoxes, the slow axial wobble of the Earth that causes the celestial pole to trace a full circle over approximately 25,772 years, has been documented as known to ancient astronomers across multiple cultures. The question was whether the Maya knew it. The long count calendar, from its zero date of August 11th, 3114 BCE, to the end of the 13th Baktun on December 21st, 2012, spans 5,125.36 years. Multiply that by 5, 25,626.8 years. The modern measured value of the full precession cycle, 25,772 years. A difference of less than 0.57%. The mainstream response is that this is a coincidence, that the long count was not designed around precession, that the Maya, who had no documented concept of axial precession, simply chose a round number of Baktuns for their great cycle. And that may be correct. But the 935-year Serpent Number interval, the one with no obvious ceremonial or calendrical explanation, is 1/27th, 6 of the full precession cycle. And this particular interval, 935 years, recurs in the Serpent Number tables not once, but multiple times, as both a direct interval and as a component of additive combinations. The probability of that clustering occurring randomly across a table that uses dozens of different interval numbers has been calculated by mathematician and archaeoastronomer Robert Aveni and found to be statistically non-trivial. Floyd Lounsbury, a Yale linguist who spent decades working within the strictest academic protocols of Maya epigraphy, who was not a popular author or a mystery enthusiast, who published in peer-reviewed journals that most people will never read, noted in a series of papers in the 1970s and 1980s that the Serpent Number based dates and interval patterns implied an observational record extending well beyond the classic Maya period. He was careful, he was qualified, he stated it as a finding, not a conclusion. His papers reached a modest audience in specialist journals, and then the broader conversation largely stopped. It was documented, it was noted, and then it disappeared. Now, let's stop here and take the skeptical case seriously, because it deserves that. Does the Dresden Codex prove that an unknown advanced civilization was conducting systematic astronomical observations 28,000 years ago and transmitted their records intact across millennia to the Maya? No, it almost certainly does not prove that. The most dramatic version of this story, a Paleolithic observatory, a lost science of precession, an unbroken chain of knowledge stretching from the Ice Age to the Jungle Codices, is a narrative that current evidence does not fully support. But here's the thing. Even the conservative version of this story is extraordinary, even if we accept the most cautious scholarly interpretation, that the Maya built their system through their own centuries of rigorous observation, that the Serpent Number base dates are mathematical extrapolations rather than historical records, that the precessional correlations are compelling coincidences. What we are still left with is a civilization that independently constructed the most sophisticated pre-modern astronomical calendar system in human history. A system accurate enough to track 4 celestial cycles simultaneously, predict eclipses with months of lead time, and maintain correctional precision across observational chains spanning centuries. All without telescopes, without computers, without any instrument more complex than a pair of aligned sticks at a known latitude. Not primitive people watching the stars in wonder, a scientific institution, a multi-generational research program, a knowledge infrastructure sophisticated enough to absorb and transmit precision astronomical data across hundreds of years and thousands of miles. From the highland observatories of Copan to the coastal sites of Chichen Itza, to the jungle storage rooms of Xultún, to the bark paper pages of the Dresden Codex. Now, here is what changes when you understand this fully. Here is where the story escalates past curiosity into something much more serious. The Dresden Codex is one of 3 surviving Maya books. 3. The Madrid Codex, the Paris Codex, and the Dresden Codex. All 3 are copies of earlier documents. All 3 are fragments of a literary and scientific tradition that was systematically destroyed in the decades following the Spanish conquest of the Yucatan. On July 12, 1562, in the town of Mani in the Yucatan Peninsula, a date and location documented in Spanish colonial records with precision. Bishop Diego de Landa ordered the burning of every Maya manuscript his soldiers could collect. His own account in the Relación de las Cosas de Yucatan, written afterward, acknowledges that 27 hieroglyphic books were burned that day, along with approximately 5,000 individual images and objects. Landa wrote that the Maya mourned the burning with great grief, that they reacted as if they had lost something of supreme importance. 27 books. We have 3. What was in the other 24? If the 3 surviving codices contain eclipse tables that still function as working astronomical instruments, Venus calculations accurate to within hours across 5 centuries, and numerical patterns that may encode knowledge of Earth's axial precession, what was in the books that burned? And Mani was not the only burning. It was the most famous. Spanish colonial records from other Yucatan settlements describe similar confiscations and destructions throughout the 1550s and 1560s. Archaeological sites, including Palenque, Copan, and Caracol, have yielded excavation contexts showing carbonized organic material consistent with large-scale document storage. Organic material that has been identified as processed bark paper, the standard material for Maya codices. The documents themselves are long gone, dissolved by heat, rain, insects, and 8 centuries of tropical humidity. The books existed. The books were systematic. The books are gone. And here is the question that the Dresden Codex, sitting undamaged in its case in Dresden, its serpent number pages intact, its impossible base dates still legible after 7 centuries, refuses to stop asking. If the 3 surviving books contain this level of astronomical sophistication, and if they are themselves copies of something older, and if that older something was itself built on a computational tradition that may predate the classic Maya period by centuries or more, then what we are looking at in that folded bark paper manuscript behind its climate-controlled glass is not the beginning of the Maya calendar story. It is the very end of a much longer one, a story whose beginning we have not yet found. And if that's true, if the Dresden Codex is the last readable fragment of an astronomical tradition that stretches back further than any civilization we currently recognize, then our history is missing a chapter, a long one that was written in red and black ink on material that burns, stored in buildings that fall, in cities that get buried under jungle growth for 1,000 years. Most of that chapter is gone, but not all of it. Pages 61 through 69 of Catalog Reference MSMCR, Dresd R.300 and 10 are still legible, still in Dresden, still sitting in that library, in that case, under controlled light that does not damage the ink. Museum visitors still walk past it. Tour guides still point at the colorful figures and mention the Mayan calendar, mention 2012, and move the group on. But the Serpent Number pages are still there. The base dates are still encoded in red ink. The calculations still reach back to a night sky that existed 26,000 years before those pages were painted. A sky watched, possibly, impossibly, by someone who was counting. Who was tracking something across the dark with a consistency and precision that should not exist in any civilization we currently have a name for. And what they were tracking is still moving above us. Every night, on a schedule they understood more precisely than most people alive today will ever care to investigate. The sky doesn't forget. The Codex is still there. The pages are still sealed within their glass. The ink is still legible. The numbers are still waiting to be fully understood. And someone should be asking harder questions about how they got there. If this investigation left you with more questions than answers, that is the only honest place to end up. Hit like if you think this history deserves more attention than it gets, and subscribe so you don't miss what comes next. The next video goes deeper into Palenque's Temple of the Inscriptions, a royal tomb sealed for 12 centuries with a sarcophagus lid covered in astronomical calculations that Mayanists still cannot fully explain. Encoding a dead king's journey through a sky no one alive has mapped. The stone is still there. The numbers are still on it. And nobody has explained them completely. We're just getting started.